Welcome to the deep dive. We've got a really interesting collection of materials today, all centered on Ruby.
Yes, the dynamic open source language known for focusing on simplicity and productivity.
Exactly. You've pulled together articles and discussions from places like Pangea.ai, Nextlink Labs, the Codist, Orbit's DEV community, even OWASP security sheets, Reddit threads, and Lemon.io. Quite a mix.
It really is a broad spectrum of views from industry analysis to developer feelings and crucial security points.
So our mission here is to kind of unpack all of that. We want to give you a clear picture of Ruby, what makes it tick, its strengths, its weaknesses.
And maybe help you figure out if it's the right choice for certain kinds of projects you might be considering.
Right. We know you want knowledge that's thorough but also efficient. So
Right.
we'll aim to deliver these different perspectives without making your head spin.
Sounds like a plan. And Ruby's origin story is quite telling, isn't it? Created by Yukihiro Matsumoto, Mats, back in '95.
Yeah, and he apparently named it after a colleague's birthstone. That's not your typical tech origin story.
It really isn't. It hints at maybe a more human-centric approach to language design from the very beginning.
I think that's spot on. That vision seems clear in how Ruby is described, even on its official site. Focus on simplicity, productivity, elegant syntax.
Natural feeling, almost. Nextlink Labs pointed out Matz's view that Python wasn't, in his eyes, a true object-oriented language.
Interesting. So Ruby was built from the ground up to be heavily object-oriented.
Absolutely. Everything is an object, and importantly, mutable, changeable. Inheritance is key. Very different foundation.
And how it actually runs has changed quite a bit too, right? That's key for performance discussions later.
Definitely. The DEV community piece lays this out well. It started interpreted, which, can be slower.
Okay.
But then Ruby 1.9 brought in YariRV. That's yet another Ruby virtual machine. It compiles the Ruby code into bytecode first.
So like an intermediate step makes it faster for the computer to execute.
Precisely. It doesn't
Yeah.
have to reread the raw Ruby each time. And then, more recently, 2.6 and onwards added MJIT method-based just-in-time compilation.
JIT compilation, that sounds even faster.
It can be. It compiles bits of the code, usually the frequently used methods, into native machine code while the program is running. It spots the hot paths and optimizes them.
Got it. Okay, so let's dig into the pros. Why do developers like Ruby so much? Friendliness and productivity came up constantly in the sources.
Yeah, that intuitive, almost English-like syntax is a huge draw. Although, as Nextlink Labs quipped, English itself isn't always the simplest thing.
Yeah, true. And there's this idea, the principle of least surprise, or PLS. Code should just work the way you expect it to.
Though what's surprising is subjective.
Right.
One dev's obvious as another's, huh? But the intent is there.
We saw comments on Reddit like, Ruby is very, very easy on the brain. That says a lot.
It does. And its flexibility seems key, too. Adapting to how developers think, things like open classes.
Where you can add methods to existing classes, even built-in ones.
Yep. And add methods ad hoc. Powerful stuff, though it needs discipline in big teams. But developers seem to find it fun.
Fun and productive. Someone on Reddit called it working pseudocode. Great for getting prototypes up fast.
That ease translates directly into development speed. Pangea.ai, the Codist, they all hit this point hard, especially with Ruby on Rails.
Ah, Rails, the framework that really put Ruby on the map for web development.
Absolutely. It drastically speeds up building web apps.
Yeah.
Great for MVPs, minimum viable products like the Codist mentioned. Get your idea out there quickly.
Pangea.ai also talked about its fit with agile development, doing development and testing together.
Right. And you often write less code. Fewer lines needed because of built-in libraries and Rails conventions like generating skeleton code for you.
Seems a lot of boilerplate, and that ties into the whole GEMS ecosystem, doesn't it?
It really does. The libraries, Pangea.ai and the Codist, highlighted the vibrant GitHub community. It's the central hub.
So these gems are just pre-packaged Ruby code snippets you can easily add.
Exactly. Solutions for tons of common tasks. And the community generally keeps them updated and pretty bug-free, according to Pangea.ai.
Impressive that it's consistently a top contributor language on GitHub.
It is, and Nextlink Labs noted the GEM system itself provides a standard format, simplifying how you manage all those different library dependencies.
Can't forget the community aspect itself. Sounds like a positive space.
Very much so. Agreeable, friendly were terms Pangea.ai used. The Codist mentioned it's constantly growing and active.
That's huge, isn't it? Sharing knowledge, best practices, that's how a technology really moves forward.
Couldn't agree more. It's integral.
Another advantage that came up was how Ruby, especially with Rails, pushes for good coding practices.
Yeah, things like DRY don't repeat yourself are kind of baked in. Pangea.ai, and the code is noted.
They also mention strict guidelines, design patterns, code by convention, active record, MVC.
Right. Code by convention means Rails has standard ways to organize things. Less setup for you. Active record is a pattern for talking to databases easily. And MVC.
Model view controller, separating the data logic, the user interface, and the controller that manages them.
Exactly. Helps keep code organized and maintainable. The codist said it promotes web standards and good engineering. Plus, a strong testing culture TDD, BDD.
Test-driven and behavior-driven development seems quite disciplined.
It encourages it, definitely. And security seems to be another plus point, particularly with Rails.
The codist and OWASP seem to think it's pretty secure out of the box.
Yes, built-in protection against common attacks like XSS, CSRF, SQL injection. The framework handles a lot of the tedious security stuff.
OWASP mentioned things like database-backed sessions being a good practice against certain attacks.
Right, and good libraries exist like Devise and AuthLogic to handle user login and authentication securely.
Okay, and Pangea.ai brought up cost. How does Ruby stack up budget-wise?
Well, the argument is that faster development means lower developer charges, potential.
Makes sense. Less time, less money.
And maybe some competition among Ruby developers helps keep project prices reasonable too.
Interesting angle. Let's talk about the language flexibility again. NextLink Labs had a strong take.
Yeah, that nothing is sacred line. You can redefine core parts of the language. That's wild.
And dynamic typing not having to declare variable types up front. That adds to the flexibility.
Definitely. One Redditor said this makes implementing pretty much any design pattern quite straightforward.
And we saw comments about scripting too. Some people prefer it even over Python or Bash.
For certain scripting tasks, yes. Some find its syntax really well suited for automation and command line tools. Extreme strength there, according to one user.
Okay, that covers a lot of the positives. But, every technology has its trade-offs. What about the downsides? Performance came up a lot.
It's the classic Ruby criticism, isn't it? Pangea.ai, Lemon.io, Reddit users. Many pointed out it's generally seen as slower than, say, Java, C++, even Python or Node.js for web apps.
Pangea.ai mentioned the Twitter story. They moved parts away from Ruby.
Yes, they shifted some back-end services to Scala, partly due to performance struggles at their scale. Though database connections and developer skill also play big roles in actual perceived speed, can definitely create latency, if not managed well.
But is it always slow? Seems like there's nuance there too.
There is. That Reddit quote was great. Ruby is not slow. It might be slower than some other comparable languages, but it is not slow in an absolute sense. Context matters hugely.
So for really huge, high-throughput applications, it might get expensive.
That's the argument another Redditor made. But they also suggested 99.9% of apps probably won't hit that wall severely, and plain Ruby, without Rails, can be pretty quick.
Right. And the language has gotten faster over time, hasn't it? That DEV community article detailed the evolution.
Absolutely. Big jumps with YRV in 1.9, then GC improvements in MJIT in the 2.x versions, and more optimization and concurrency stuff in 3.x. The benchmarks show significant speedups.
So while the reputation for being slower persists, the reality is more complex and improving.
Exactly. It's often a trade-off. Right. You might trade some raw speed for that development speed and maintainability, which might be perfectly fine or even preferable for many projects. The new concurrency features in Ruby 3, like reactors, also open up new possibilities.
That segues nicely into scalability concerns, related to performance, obviously.
Yep. Lemon.io suggested bigger apps might hit performance clogs compared to more optimized languages. The codist also flagged potential scaling issues with large user bases.
But Arabits had a different take, right? That scaling is possible with Rails.
Yes, they argued it's often more about the architecture than the language itself. Things like poor app design, slow database queries, lack of caching, not enough server power. Those are often the real culprits.
So it's not that Ruby can't scale, but you need to architect for it carefully.
Precisely. They talked about solutions, vertical scaling, bigger servers, but that has limits, and horizontal scaling, more servers, load balancers, separate database instances.
And caching strategies, background jobs for long tasks.
Crucial.
Yeah.
Plus database tuning. It's definitely doable, but requires deliberate effort.
Okay, another interesting con was actually related to flexibility, but at the framework level, Rails being too rigid sometimes.
Kind of the flip side of its convention over configuration strength. Pangea.ai noted that sticking so closely to standards can make it hard to change core behaviors or deviate too much.
Some configured parts are hard to modify, potentially forcing a move to other tech.
In some cases, yeah. The codist mentioned that adding really non-standard features might take longer because you're fighting the framework's assumptions a bit.
But isn't that rigidity sometimes a good thing? For consistency in large teams.
That's the trade-off, exactly. It ensures a certain level of predictability and makes it easier for new team members familiar with Rails to jump in, but less freedom for bespoke solutions.
Another area of concern, documentation, specifically for third-party gems.
Right. Pangea.ai mentioned it's not always up to date, especially for less popular gems. That can really slow developers down digging through source code or outdated examples.
One Redditor called Ruby Docs overall, okay, a bit better than mediocre, but far away from very good.
Ouch. Another compared it unfavorably to Python's documentation ecosystem, suggesting Python has more consistently updated resources.
And what about Ruby's overall popularity and the size of its ecosystem?
That came up too. The codist called it maybe more of a niche language, not always the first back-end choice.
Which could mean fewer developers available, harder to hire.
Potentially, yeah. The codist and Reddit both mention this. You might need to look harder, maybe hire remotely more often than for Python or Java devs.
Stack Overflow surveys seem to reflect that lower popularity ranking as well.
And Lemon.io and Reddit pointed out this can mean fewer resources, fewer libraries overall compared to the really big languages.
Some Redditors felt it's lost steam from its peak popularity, with languages like Go gaining ground.
Yeah, that I wish it were more popular comment was telling. It impacts things like whether a news service releases a Ruby SDK right away.
And the focus on web development means non-web stuff might be harder, fewer specialized libraries.
That was another point raised on Reddit. And a specific lack of strong math libraries compared to Python, which is huge in data science, partly for that reason.
So if someone's project relies heavily on, say, complex math or needs a very specific non-web library, Ruby might not be the easiest path.
It might require more effort finding or building those tools yourself compared to a language where they're readily available and mature.
Okay, let's revisit flexibility, but as that double-edged sword.
Right. Nextlink Labs warned that Ruby's malleability, being able to change almost anything, can lead to messy code bases if developers aren't careful, especially on larger teams.
Makes code harder to read, debug, expand later on.
Potentially, yes. And they also touched on how Ruby's surface simplicity can hide complexity, especially with metaprogramming.
Metaprogramming, where code can write or modify other code at runtime.
Exactly. Super powerful, allows for very concise frameworks like Rails, but can make it really hard to follow what's actually happening under the hood, can lead to unexpected results.
We even saw a Reddit comment that some newer Ruby 3 syntax wasn't universally loved, maybe adding complexity. I can imagine debugging really heavily metaprogrammed code could be a nightmare.
It definitely requires a certain level of expertise and discipline to use well.
Then there was a more technical point about system integration from Reddit. RubyGems not integrating with system package managers.
Yeah, like apt or brew. So if a gem needs a C library to compile its extension, the developer might have to manually install that library and the compiler tools first, an extra step.
And finally, legacy code, even in the standard library.
Another Redditor mentioned this. Some older parts of Ruby's standard library and some widely used gems have APIs that feel a bit clunky or awkwardly designed by modern standards. NetTDP was one example given.
Okay, so lots to consider on the con side. Let's pivot to a deeper dive on security, building on what we touched on earlier. OWASP had a lot to say beyond the basic Rails protections.
They did. It's crucial because while Rails helps a lot, developers still need to be vigilant. Command injection is a big one.
Using things like evil, system, backticks with user input, very dangerous.
Extremely. OWASP stresses using allow lists for commands and validating all user input rigorously. Even with active record in Rails, SQL injection is possible if you manually build SQL snippets from user input without proper sanitization. Use methods like sanitize click.
What about cross-site scripting, XSS? Rails protects by default, but there are ways around it.
Yes, using raw or HTML safe in views bypasses the protection. OWASP warns that HTML safe is inherently unsafe if the source string isn't truly trustworthy. They recommend things like content security policy, CSP headers, and using the hashtag sanitize method carefully. Older Rails versions had issues with JavaScript in links too.
Session management OWASP prefers database-backed sessions over the default cookie-based ones.
Yes, to better guard against replay attacks where an attacker steals a session cookie and reuses it. And always enforce TLS HTTPS for the whole site, for SES and Rails.
Authentication isn't built in, so use libraries like Devise or AuthLogic.
Correct. And enforce strong passwords. Token authentication is another option. Then there's IDOR Insecure Direct Object Reference.
Because Rails URLs can be predictable, like users 1, users 2. Someone could guess URLs to access data they shouldn't.
Exactly. So you absolutely need authorization checks in your controllers. Libraries like CanCanCan or Pundit help manage those permissions.
CSRF cross-site request forgery. Rails has protect from forgery, but watch out for exceptions.
Right, and remember, GET requests aren't protected by default. It's less relevant if you're only using token authentication, though.
OSPale also mentioned risky redirects and dynamic render paths.
Yeah, if you redirect based on user input, params.to, validate that URL carefully to prevent phishing or XSS. Use .only path or check against an allow list. And don't let user input dictate which view template gets rendered via the render method.
Course configuration is important for APIs allowing cross-domain requests.
Essential. Use the rat cores gem to tightly control allowed origins, headers, and methods, and set security headers like HSTS, via ForceSSL, and others, maybe using the secure headers gem.
OWASP also stressed non-code things. Code reviews, pair programming, unit tests for business logic bugs.
Absolutely critical. And understanding your attack surface defined in routes.rb. Avoid overly generic routes. Protect sensitive config files.
And encryption, don't roll your own.
Never. Rely on OS-level encryption or standard libraries.
Yeah.
Devise uses bcrypt for password hashing, which is good. Finally, keep dependencies updated. Use security scanning tools like Breakbin.
That's a comprehensive security overview. Okay, let's circle back fully to performance and its evolution, drawing from that DEV community piece. The early days, 1.0 to 1.8.
Purely interpreted. Slow. Ruby 1.8 with Rails was popular, but performance was a known bottleneck. No native threads, no bytecode. That Fibonacci benchmark took maybe 5.5 seconds.
Then 1.9 was the big shift with YRV.
Huge shift. Bytecode compilation, faster method dispatch, cut that Fibonacci time down to around 3 seconds, a massive improvement.
And the 2.x series focused on more speed, GC improvements, MJIT.
Yep. Better garbage collection, Argent GC. Optimizations like frozen string literals, and then MGIT in 2.6. That just-in-time compiler brought the Fibonacci time down again, maybe to 1.5 seconds.
So steady progress. And Ruby 3.x promised even more, like 3x faster than 2.0.
That was the goal. More MGIT improvements, a new fiber scheduler for better concurrency, better GC, less memory use, and Ractors for true parallelism.
Raptors sound interesting, allowing truly parallel execution.
Yes, unlike threads, which are limited by the Global Interpreter Lock, GIL, for many operations, Ractors are more isolated and can run Ruby code in parallel on multiple CPU cores. That Fibonacci time with MGIT and 3.x, maybe around 1.0 seconds.
It's a significant journey from 5.5 seconds down to 1 second for that benchmark.
A very significant journey. The DEV community article showed this clearly and also highlighted advanced techniques.
Like enabling MJIT with the JIT flag.
Right, and using Ractors for parallelism, tuning the garbage collector with GC Profiler, using profiling tools like Benchmark, StackProf, RubyProf, FlameGraph to find the actual bottlenecks in your own code.
And specific Rails optimizations. Caching. Eager loading.
Crucial for web apps. Rails.cache for caching data or view fragments. Eager loading with includes to avoid N+1 query problems where you make tons of database calls in a loop.
And memoization. Storing results of expensive calculation.
Yeah, saving the result in an instance variable, so you only compute it once per request or object lifecycle. These techniques, as their final benchmark showed, can make a huge difference on top of the language improvements.
Okay, so wrapping this all up. It's clear Ruby presents, well, a really interesting mix.
Definitely complex. You've got this incredible developer productivity, the friendly community, the power of Rails for web dev.
But balanced against those historical, though improving, performance and scalability concerns, and the need for real security diligence.
Absolutely. The choice really hinges on the project specifics, doesn't it?
Yeah.
What are the performance needs? How important is rapid development versus raw speed? What's the team's expertise?
It really depends, which leads to a final thought for you, our listener.
Yeah. Thinking about Ruby's journey, prioritizing developer experience sometimes over raw speed, what does that suggest about the future, especially in the cloud era where maybe raw efficiency per CPU cycle is balanced differently against development cost and speed?
Is that trade-off between developer happiness and peak performance always necessary? Or is the gap closing?
It's something to ponder. Languages are constantly evolving, and priorities shift.
A really interesting question. So, if this deep dive sparked your curiosity, definitely check out the resources we mentioned. Maybe even spin up a small Ruby project yourself.
Get your hands dirty, see how it feels.
Exactly. We'd love to hear what you think. What are your own experiences or conclusions about Ruby? Let us know.